Hello everyone, welcome to the video lecture series of Internet of Things. From today onwards, we are going to study course Internet of Things, which is included in semester 7 of 4th year program of Electronics and Telecommunication Engineering course. Before starting with the content, I would like to introduce myself. I am Professor SITRC from Electronics and Telecommunication Department of Sandeep Institute of Technology and Research Center, Nasik. I am having 10 years of teaching experience and domain expertise of 10 years in Internet of Things. Let us discuss the course structure of Internet of Things. The examination of Internet of Things is divided in theory, term work and practical. The theory examination is divided in SEM examination and NSEM examination. The NSEM examination will be of 30 marks and which will be based on first 3 units of Internet of Things. And the NSEM examination will be of 70 marks. Total credit for the theory examination is 3. The term work and practical will be conducted at the end of the semester, each of having 50 marks. It will be conducted along with the VLSI course. The credit for the term work and practical is 2. Let us discuss the course content. In this Internet of Things course, we are going to study 6 units. Unit 1 is Fundamentals of IoT. Unit 2 is Sensor Network. Unit 3 is Wireless Technologies for IoT. Unit 4 is IP-based protocols for IoT. Unit 5 is Data Handling and Analytics. And Unit 6 is Applications of the IoT. Let us discuss the course objective. On completion of the course, student will be able to study the fundamental concept of IoT, to understand roles of sensor in IoT, to learn different protocols used for IoT design, to be familiar with data handling and analytics tools in IoT. Let us discuss the course outcomes. On completion of the course, student will be able to understand the various concepts, terminologies and architecture of IoT systems, use sensor and actuators for design of IoT, understand and apply various protocols for design of IoT systems, use various techniques of data storage and analytics in IoT, understand various applications of IoT. Reference book for Internet of Things are as shown on the screen. Practicals for IoT. A project-based learning approach will be followed for this course. Hence, the experiment will be small project to be built by the student. And figure shows the suggested list of experimental project. Minimum 6 are to be performed by the students. Now let us discuss the Unit 1, which is Fundamentals of IoT. The content in Unit 1 are Introduction, Definitions and Characteristics of IoT, IoT Architectures, Physical and Logical Design of IoT, Enabling Technologies in IoT, History of IoT, About Things in IoT, the Identifiers in IoT, About the Internet in IoT, IoT Frameworks, IoT and M2M. Now let us discuss first the introduction to the IoT. The Internet of Things. Things refers to device like Bluetooth, connected handset, thermostats, utility meter temperature reader, sensor, actuators, etc., which can sense some parameters. In IoT, these things are connected together to generate some meaningful results. In IoT, each of these things have independent identities and can be connected over a network for data sharing. Definition: IoT is a global network of things, that is, physical and virtual devices having separate identity to each one of them, which can be connected via a vast network to share data and process it into meaningful information to generate some meaningful results. In IoT, each of these things has independent identities and can be connected over a network for data sharing. Characteristics: IoT-based applications and services can be distinguished from some well-defined characteristics. First, unique identity, interoperable communication protocol, dynamic and self-adapting, self-configurable, integrated into information network. Characteristics: unique identity. In IoT-based application, multiple things of same utility are usually deployed. To coordinate effectively between these things, each of these have unique identity. IoT systems have an intelligent interface that manages the system based on these unique identities of things. These things can be monitored, updated, and controlled remotely because of the unique identities. Second, interoperable communication protocol. IoT-based applications have multiple things deployed in the network which can communicate. Various protocols are available for device-to-device and device-to-infrastructure communication, that is, device of same type or different type. Dynamic and self-adapting. IoT-based applications and devices are made aware of environment in such a way that change in parameters of their surrounding changes the context, and the IoT application can accommodate such changes based on user context. Such intelligent systems can be designed and are called as self-adapting IoT applications. For example, a surveillance system has camera with capability of infrared night mode and normal mode. Based on the surrounding environment, camera should be able to switch between normal mode and night mode. Doing so, a central camera can also send notification to other camera about doing the same. Changing the resolution based on light availability is one more dynamic behavior of camera. Self-configuration. Most of the small IoT devices such as sensor, actuator, etc. once deployed has very less direct user interaction. Due to this, many of such devices are capable of fetching the latest software updates, set up basic networking and status checks themselves or with very less user intervention. Such devices work together to generate the results. For example, weather monitoring system. Integrated into information network, IoT devices are typically configured in such a way that they can communicate between other devices in the IoT-based environment to create an information network. IoT devices can describe themselves using the unique identity to other devices or to a network and are dynamically discovered in the network by other devices and or network. For example, in weather monitoring system, multiple sensors can communicate to other sensors or a central node in a network. This capability makes the IoT application smart. This data from large number of devices are collectively merged together to generate meaningful information. Now let us discuss IoT architecture. IoT architecture can be explained in two specific ways. First, the general overview of IoT, where how IoT is designed and looks in general perspective. And second, how it actually communicates and what are the actual protocol used throughout various layers. Device and sensor, then communication of device and application, then serving a web services, resource management, a security, and lastly the applications. Device and sensor is the hardware part. The middle part, that is serving web services, resource management, security and communication of device and application, is the business logic. And the uppermost part, that is application, is the front end. First, device. The device or things in IoT based system provides functionalities such as sensing, actuating, communicating, monitoring and controlling. This is actual hardware part of an IoT based system. An IoT system requires a business logic that manages the whole blocks. Communication. Communication block handles communication between various devices and central nodes using various protocols. Third, services. An IoT system uses numerous services for device controlling, device detection, device monitoring, and device controlling etc. Management. An IoT system provides various functionalities like turning on LEDs, buzzing alarms, etc., which are activated on certain conditions. All such functions are governed via management block dictating which function should execute and when. Security. Security manages authorization, authentication, integrity, and data security in an IoT systems. Applications. An IoT system manages various things and notifies user about any condition or generate result based on sense data. Applications are needed to represent such data relevant to the user. Applications are also used to control and monitor such IoT systems. This is front-end part of the IoT application which is accessible to the user. IoT devices communicate with each other and central node seamlessly throughout the internet network. For this communication to happen smoothly, various protocols are available in various layers of internet protocol suite. Protocol architecture of IoT. First is the link layer, which consists of 2G, 3G, LTE cellular network, 802.3 Ethernet, 80.211 Wi-Fi, 802.15.4 LRWPAN, 802.16 WiMAX. Next is the network layer. It is IPv4, IPv6, 6 LOWPAN. Next is transport layer. It is of TCP and UDP. Applications layer protocol, COAP, WebSockets, XMPP, HTTP, DDS, MQTT, AMQP. Summary of the lecture. In today's lecture, we studied course structure of IoT, course content of IoT, course objectives of IoT, course outcome of IoT, introduction to IoT, its definition and characteristics of IoT, IoT architecture. Thank you.